Welcome to another ICS Village production. The ICS Village is a non-profit organization dedicated to the promotion of industrial control system security. Visit our website at icsvillage.com to discover more about us, where to find the village, participate in our community engagement project, and how to sponsor and donate to the ICS Village efforts.
Welcome all. Miriam and I are honored to be here in front of ICS Village. Both of us are members of the Dragos Professional Services team, and that means that we perform dozens of network architecture reviews for industrial organizations, large and small. So today we are here to talk through 7 of the top most common critical findings that we find within our client architectures. These are misconfigurations, poor practices, and anti-patterns that jeopardize the security of the underlying OT network. I'll figure out how to work the clicker here. Give us 1 sec. We're having trouble with the clicker. All right, whoops. It looks like I need to stand over here while I'm presenting, so I'll do that. First, let's introduce ourselves. I'm Nate Pelz. I'm in primary role as an incident responder at Dragos. That means that I help our client organizations react to and recover from intrusions in their OT networks. But at Dragos, I've also performed many proactive network architecture reviews. Some of my previous work has been in security, risk, and vulnerability management, SOC work, and web application development. So nice to meet you all. Miriam?
Thank you. Hi everyone, Miriam Lorbert. I am a senior industrial consultant at Dragos. I have gotten here by way of electrical engineering and a cybersecurity schooling and work background, and we're currently the subject matter experts for performing these types of vulnerability analyses in our customer environments. So I just wanted to give a quick overview to level set everyone in the room and talk about some concepts that we're going to be discussing and reverting back throughout the presentation. So this is the Purdue Model, which is the recommended network architecture design in operational technology or industrial control system environments. And it's set up as a layered defense approach through starting level 4 is your IT network. So that's something that you might have an IT laptop corresponding with on a daily basis. And then going down to level 0, which is the actual process telemetry that's touching your industrial control systems or your operational environment. So we're going to focus on levels 3.5 and below. We're going to start at that boundary, and that is going to be what you see in the red box is our focus area for these findings that we're going to talk about. And our goal when doing these vulnerability analyses or architecture reviews is to evaluate the security posture of our customers, identify any vulnerabilities, and then provide actionable intel or recommendations to them to follow up.
Okay, so let's get started with our critical findings. So our first finding relates to a defensible network architecture. So you can't defend your network if you don't have a defensible architecture. And so that's why one of the most impactful findings that we see that jeopardizes security is an architecture where lack of segmentation between the corporate IT network and the OT network exists. So let's dive into an example. Here's a sample IT-OT boundary. You can see on the top we've got your internet-facing systems in your corporate IT network. On the bottom we have your OT systems for process control. At some sites we see these configured in a way that looks like this. We see the systems around maybe a single switch. And if your IT and your OT systems live on the same LAN, then that is considered a flat network because there is no meaningful segmentation between IT and OT. But even if there are multiple switches or routers that separate your systems, even if they live on different subnets, if there are no access control lists that are restricting that traffic from IT to OT, we still consider this a flat network. Because any device can communicate with any other device. So we've unfortunately seen this configuration across organizations both small and very large, from electric power to manufacturing to wastewater. And the consequences can be pretty terrible, because if an adversary is able to compromise even a single IT workstation with something as simple as a phishing attack, there is little to stop them from moving laterally to your crown jewels. Like our IR team observed in a ransomware case we responded to last year, where an energy company was devastated by ransomware and had to rebuild their entire domain. So a firewall between your IT and your OT is a great first step. But what restrictions is that firewall enforcing? Let's take a look at this example firewall rule set. Can you find the holes within that allow an adversary to move through? Any? Yes, so every cell that's highlighted red here is actually unnecessarily broad for the workflow that it's supposed to be allowing. So in this case, we can see that an adversary on Bob's PC can access any system on the OT network over any port and any user. Every OT workstation has access to email, which is probably not required for daily operation. And every device on the OT network has access to the internet over port 443 HTTPS, which can be used for adversary command and control. So much better is making sure every traversal is scoped to specifically limit the permissions that are allowed to it, down to making sure that only the exact workflow you are intended is actually allowed. In this case, Bob only needs to interact with his engineering workstation over RDP, and he only needs his user account. Only Jill's operator workstation actually requires email for daily operations, and only the SMTP service user needs that permission. And only your Red Hat Enterprise Linux update server actually needs internet access, and the only site it needs to hit is the Red Hat update website. So this is an example of stronger segmentation because the holes in the firewall are much smaller. So in summary, the best practices that we recommend every organization follow when building your access control lists. 1, make sure to scope down all workflows to the minimum possible permissions necessary in every category. Never use any unless you are denying traffic in that access control entry. And never allow direct outbound internet or inbound internet access. And if it is absolutely business critical, then make sure you are restricting that workflow as much as possible with users, systems, ports, protocols, and services. Now, enforcing that logic against 2 separate firewalls with a DMZ in the middle, that is an example of true IT-OT segmentation. And this brings us to our finding number 2, which is a lack of OT DMZ. Now, at Dragos, we've interacted with a few organizations who have otherwise good segmentation, but they don't have a DMZ, and they don't necessarily understand what the purpose of a DMZ is. Maybe there's some confusion around the risks and the benefits, like why do we need one if we have really good firewall logic? So let's go through the basics of what is an OT DMZ. It's an entire network segment between your corporate network, which is lower trust, and your OT network, which is higher trust. And so some examples of systems we see within a DMZ, you might have a jump host to allow remote interactive sessions to go down and up. You might have a file server that allows passing files down to OT, or an update server, an antivirus server for passing updates and configurations down to OT. You might even have a data historian node for passing process control information up to corporate. You don't need to have all these systems in your DMZ, but what you do need is the fundamentals. And there are two fundamentals. One, both incoming and outgoing traffic needs to be restricted ideally by an access control list or by firewalls. So that's why we've got a firewall on top and a firewall on bottom. Two, all traffic needs to terminate in that DMZ, which makes that DMZ a network choke point. Now an immediate question that might come up is, what's the point of two firewalls? If an adversary can get through the logic on one firewall, can't they just get through the logic on the second firewall? And you're right. If both firewalls enforce exactly the same logic, then there's not much of a point of that second one. So, for example, in this situation, let's say that your organization needs to pass project files down from corporate down to OT. If you allow SMB by a certain user into your DMZ, and then you allow SMB with the same user down to your OT, then that second firewall isn't doing a whole lot for you. But there is a better way. What if instead you allowed SMB to come through corporate down to your DMZ, but then you only allowed SMB to come up from your OT, so that way your OT engineers can still fetch the project files they need, but an adversary trying to come down through corporate is restricted. That is an example of a more secure setup because you're implementing different access controls on each firewall. And you can use a similar setup no matter what server in your DMZ. Now there are some situations like what we've got illustrated here where we are passing down remote interactive sessions through a jump host. And in these occasional setups, it's really, because the traffic really does have to flow this way, it's difficult to really implement two meaningfully different access control lists on these firewalls. So in a few cases, that second firewall might not be doing that much for this workflow. But even so, having a jump host in your DMZ is still a best security practice because of the second benefit of DMZs. Remember, there are two. And the second benefit is that DMZs serve as a network choke point. So in this illustration, we can see we've got a lot of IT systems communicating to a lot of OT systems. There's no network choke points. Traffic is not communicating, is not terminating in any intermediary device. And so what this means is that some security best practices, like hardening devices on the OT boundary, or enforcing multi-factor authentication on devices on the OT boundary, monitoring connections across the OT boundary, all of those become a lot more difficult because you have so many devices on your OT boundary. So a better approach is a network choke point in your DMZ. Now you've only got one system, or maybe a couple systems, that you can harden, that you can enforce multi-factor authentication on, and you can monitor in your SIM. So all of a sudden, we have a defensible network architecture. So this is the network choke point. This is the second benefit of a DMZ. Okay, let's move on to finding number 3. Now this is another finding that we unfortunately commonly find, but it has pretty serious security implications, which is a shared IT and OT user management. So to illustrate this, let's look at our sample DMZ workflow, or our sample network diagram. Our professional services team occasionally comes across a network that looks like this. One Windows domain within Active Directory across both IT and OT, domain number 1. This might be convenient for your sysadmin to manage, but it is not an example of a defensible network architecture. And the reason is that there are certain protocols that are required for Active Directory to function that need to be allowed down from the IT through to OT systems. And these protocols can be abused by an adversary. It also means that if an adversary compromises your domain controller in your corporate network, then they can deploy ransomware to your OT devices. It also means an adversary can create new user accounts for long-term persistence that have both IT and OT permissions. So this is not great. A better setup is the following: 2 separate domains, one for IT, one for OT, with no domain trust that's shared in between them. What this means is that when your users on your IT want to communicate or want to pass down to OT, they first have to authenticate on the IT-OT boundary with a separate set of credentials. This means that your 2 domains are going to have separate domain controllers controlling their respective domains, and they won't be able to communicate to each other. It means that even if there is a full domain compromise on your corporate network, an adversary is still not going to be able to get to your OT systems. Now, this architecture isn't free. You do have to maintain 2 domains, and your users who need to pass through both, which hopefully aren't very many, will need to manage multiple sets of credentials. But we strongly recommend all organizations implement this architecture because the friction to legitimate user workflows is minimal, but the security benefits are huge. You can even take it a step further and have 3 domains. You can have a 3rd domain in your DMZ. Now this is extra secure, and it's a lot of work. You do need to manage a lot of credentials. It can get complicated. We don't consider this a critical finding if we find organizations don't have 3 domains. This is only for organizations that are willing to put in the extra work to have that extra security maturity, but it does really restrict adversary workflows. It really does, yeah. So those are the first 3 findings. For the rest of our findings, we're going to pass it off to Miriam.
For the next finding, we wanted to cover unverified trust in external connections. So first, what is an external connection? It is any communication that happens beyond a defined security perimeter. So in our case, going back to that Purdue Model diagram, we're going to focus on the level between levels 4 and 3, specifically level DMZ, level 3.5, which in most cases is that defined security perimeter. So in this case, we go back to our diagram and we see that we've introduced into level 3, not going through our DMZ, we have a third-party application server. And it may very well need to be located on level 3, and it's not something that can pass through the DMZ. However, what we might not know or see or have researched beforehand is the way that this third-party application server works in our environment. It is actually connected to a third-party cloud instance. So we're opening ourselves up, unbeknownst to us, and accepting the security posture of our external connections. So it's really important that we go through and and put the effort in to do that due diligence, to understand what our third-party connections or any external connections are, where are they going, and what kind of security posture are we opening ourselves up to. And there are a couple of things that we can do in the process, again, if it applies to the environment. Number 1 would be making sure that everything is routed through your DMZ or jump server. So you have that network choke point, you have that area of increased logging and monitoring. So if there's something about the security posture of the external connection that you're unaware of, this will help give light into what you might not have seen on the forefront. Another one is to have lockdown firewall access controls. So make sure that your rules are very clearly defined and everything is specifically allowed in your rules that needs to occur. And then a step further is to make sure to have a rule at the end that will deny any other traffic that you might have missed, any other cases, putting in that extra layer of defense. And as I talked about for the DMC, to have that increased logging and monitoring, we also want to make sure that we can apply it to anywhere level 3 and below to enable multi-factor authentication when we can, to enable any logging and monitoring to help with our visibility into that side of the house. The next finding is insufficient network vulnerability and monitoring. So we don't know what we don't know, or we don't know what we can't see. So what can we do about this? Let's talk about what we could possibly find with increased visibility. The first set of items is identifying and managing the assets that are in our environment. So some ideas are gonna pop up on the screen that are examples of the categories that I'm talking about. Next one. The next one is gonna be monitoring and just visibility into the categories of assets that we now know and understand are on our network. And now that we understand the communication that's happening on our network, we can figure out what malicious activity or what behavior or communication isn't normal for those devices. And this point is so important, that your OT visibility should validate any security controls that you have in place. So it is a check for you, making sure that the security controls you have in place are working. And if you are seeing suspicious traffic and you notice areas that need more security controls or mitigations, then this will help you identify what those areas are. So this finding is for tracking PLC key switch modes, which is a little bit off-center to what we've discussed so far. So we're going all the way back down to level 0 and level 1. So we're touching the process, but it's kind of also a subset of visibility into our environment. So as some of you may or may not know, PLCs and safety instrumented controllers usually have a physical switch that is integrated into the hardware of the system. And it's usually in the form of a key switch. Now, specifically, we're looking at a picture of a Triconix PLC. There are multiple types and different vendors, and they all have their own naming convention when it comes to the different types of modes. So we'll discuss the definitions for these modes, but understand that it may be a different naming convention for a different vendor. So just touching upon the ones that might make the most sense or maybe the most intuitive, we have run, which will run normal operation and only allow read-only inputs. And stop will stop reading the input variables and stop the program. Now let's talk about the two that look kind of suspicious. So we have remote, which it doesn't allow for program or logic updates, but it does allow write access from external hosts. And then we have program, which also allows for write access from external hosts, and that one will actually load program or logic changes to your PLC. So this is an example of what happened with the Trisis malware. It was able to remotely access a PLC and make changes because the PLC was left in program mode. So the mitigation here is to make sure that we track the current status and any changes in our key switch position. So it's not to say never put the PLC in program or remote. It's gonna happen. It's gonna have to happen as we're making firmware updates, logic updates, as our process is growing and maturing and we're making changes. But that could, it may only be necessary that that's a 10-minute window. So if you are able to keep track of the key switch status, you can understand if it might have been left there too long, or maybe someone is affecting and changing the key switch unbeknownst to you, so you can track that as well. And this became something so important seen in industry that it became the #2 recommendation for the secure PLC coding practices, is to track your operating modes based on this key switch for PLCs. Our last finding, we'll talk about insufficient ICS-specific cybersecurity recovery procedures. I know it's a mouthful. So let's talk about some do's and don'ts. These are the don'ts, which is some examples of things that we'll find in our client environment. So they're lacking knowledge into their ICS or OT environment. They're lacking formalized or sufficient ICS-specific procedures. So a lot of times on the business side or on the corporate side, these procedures will be robust and built out, and you'll have your formalized programs, but not relating to ICS-specific nature. They don't leverage strategic partnerships or potentially have incident response retainers, and they lack routine reviews to update the process and procedures as needed. So let's talk about some things that we can do. Number one, the most important, you can't do any of the rest of them without it, is understanding your process, understanding your physical process, what are you there to do, and then understanding the ICS network and environment that's running to help keep those in place. Increase visibility, which is your logging and monitoring, and also configuring and maintaining your retention policies for those logs. So if an incident happens and you are only aware of it 6 to 8 months from now, you want to make sure that you're still able to go back and look at those logs when needed. Have documented ICS-specific recovery procedures, and this is the most important part, is to have a defined roles and responsibilities in there. We've seen a couple of cases where there are such great ideas, technical ideas flying, and you could tell that the group really knows how to respond to a specific type of incident that we're discussing, but no one has taken command, there's no chain of command, there's no one who wants to make that final decision to say, okay, let's do this to mitigate, let's do this to isolate this point that we have. Establish those incident response retainers and strategic partnerships. So if your environment allows, you can set up an incident response retainer, which will have people like Nate come and help you with your incident response, should it happen. Or strategic partnerships with vendors, people in the like industry, just sharing information and knowledge such that should an incident occur, you have a bit of a support group and you're not reinventing the wheel. And then finally, test your systems. Test your systems, test your people, such that if something happens, you know everyone in the room is prepared. Thank you so much to ICS Village and DEF CON and our audience, and Dylan for helping out with everything. Are there any questions?
On understanding your network, when you guys, to understand your network, are you just going back and saying, hey, let's just physically map anything, or are you doing active terrain mapping, or are you saying, hey, I can instrument or sensor my network with, say, like a Drago sensor, and then deduce what my network topology is from that point?
It depends on the resources that are available to you. So if you could put in a sensor to help map out your network, that would be great. But it could be the case where we come on site to a client's environment and there are no network diagrams. So, you know, to an extent, there should just be that foundational information, even block diagrams of what's connected to what and what protocols they're using. All right, thank you.
Thank you for joining us for another ICS Village production. Be sure to like and subscribe to the channel. Find us on icsvillage.com to become involved with our community.